Hello everyone and welcome. Porsche Taycan versus Tesla Model S. Now, how in the world is the Tesla capable of literally double the Porsche's range? 402 miles versus 201. That's a question I've been trying to figure out for quite some time, and the speculation often goes as follows. Tesla is cheating and lying about their actual range figures. The EPA is in love with Tesla and gives them favorable results. And Porsche is essentially sandbagging, understating the true range of their cars by publishing conservative figures about their range. And the beautiful thing is Dave Vanderwerp of Car and Driver smacks all of this silly speculation in the face with cold hard facts. It's the best article I've read all year, and I'd encourage you to pick up a September 2020 issue of Car and Driver next time you're at the grocery store. It's the one with it. Look on the cover. There's a red Ferrari, and what is that? It's like a fancy Volkswagen. No, that looks like that's the new Corvette. So it's got a Ferrari Corvette. You'll know. Anyways, buy the magazine. No, this is not sponsored. Turn to page 52 and gorge on facts. In this video, we're going to focus on the two parts I find the most fascinating and dive a little deeper: EPA testing and road load. Okay, so there's 5 categories here explaining why the Tesla has so much more range than the Porsche. So let's start off with EPA testing. So where does this Porsche Turbo's 201-mile range actually come from? So for the EPA testing, of course, there are city tests that have to be done to get that city MPG rating, and there are highway tests that have to be done to get that highway MPG rating. So this is a 2-cycle approach within the EPA testing that all the manufacturers are going to do. And so what Porsche does is they put their car through these tests and they end up getting a range estimate out of these tests. So let's say that range estimate ends up being 287 miles. Well, here's the thing. These EPA tests are really easy to do really well on. It's not real world. It's not going to give you what your actual range will be in the real world. And the EPA knows this, so you have to apply a correction factor. In this case, for this simple 2-cycle system, the correction factor is 0.7. So let's say, for example, Porsche runs their 2-cycle testing and their range ends up being 287 miles. Well, they multiply that by 0.7, and what do you know? They get a total range of 201 miles. Okay, so how does Tesla get their 402 miles of range? Well, they undergo that exact same 2-cycle city and highway testing to come up with their range estimate, and let's say that number ends up being 541 miles. Well, if you multiply that 541 miles by that 0.7 correction factor, you get a range of 379 miles. But of course, the Tesla range is 402 miles. It's not 379. So where does that 402 come from? Well, what the EPA allows you to do, instead of taking this just standard 0.7% correction factor, you can actually come up with your own correction factor by undergoing 3 additional tests. So there's an acceleration test, a test that requires you using your air conditioning system, and a test where you're driving in the cold, 20 degrees Fahrenheit. And so if you do all of these 5 cycles here, you divide that by your 2-cycle results, you get a correction factor. And for Tesla, that number ends up being in the range of 0.705 to 0.756. The higher the number, the better here, because it means you're taking less range off of your estimate. And so this is the range they end up falling in throughout their product lineup, whether it's the Model 3, the Model Y, the Model S, etc. So for this Model S Long Range Plus, that correction factor ends up being 0.743, which when you multiply that by 541 gives you a total range of 402 miles. Now, is it dumb that not all vehicles are undergoing the exact same testing? And yes, I think that is dumb. I think there should be consistency among all the electric cars. So why is it this way? Well, basically, the manufacturers are like, we don't want to do all this extra work. So they're like, EPA, we don't want to do all that extra work. And then the EPA is like, well, okay, you can multiply it by 0.7. And it's not quite that simple, but that's the basics of the story. And so, Tesla's going the extra effort in order to, show that they have very good range. And ultimately, they're only gaining 23 miles here. So the car is 402 versus 201. The reason why they're up so high is not purely because of this EPA testing. They're only getting 23 of those extra 201 miles through this EPA testing. So the only 2 companies currently that are doing the extra work to try and boost their scores are Tesla and Audi. So It's not all EPA testing here. That's the deal, and that's why we're going to show these other 4 categories of what's actually making up this 201-mile deficit that the Porsche Turbo has. So the next 3 factors we'll just touch on briefly, starting with battery capacity. Of course, if you have a larger battery, you get to go further. That's how it works. You have more energy stored on board, so you can drive farther. And that is the case with the Tesla Model S. So the Porsche Taycan has a 93.4 kilowatt hour battery. However, they only allow you to use 83.7 kilowatt hours of that battery pack. So their effective battery pack size is 83.7 kilowatt hours. That's how much energy you have to use, and they save that rest as a little buffer to make sure that battery lasts a long time. Now for the Tesla Model S, they're a bit more sketchy about sharing all of this information, so we don't really know the exact sizes and how much they block off, but it's about a 100 kilowatt hour pack, and they seem to allow you to use more of that battery. So let's say they allow you to use 95%, leaving just a 5% buffer rather than a 10% buffer like the Porsche. That's an extra 11.3 kilowatt hours over this Porsche battery, which in terms of range, based on its combined fuel economy rating, means this has another 39 miles just from the fact that it has a larger battery. Moving on to regen and motor efficiency, Tesla also seems to have a powertrain efficiency advantage over Porsche. You can read more about that in the Car and Driver article, but they also employ a very different regen strategy. And so in the Porsche Taycan, when you let off the accelerator pedal, it basically just coasts in neutral. When you do that in the Model S, when you let off the accelerator pedal, it is giving you aggressive regen, so taking that energy and putting it back into the car by slowing down the car, putting that energy back into the battery. And so the Porsche Taycan is only doing this if you start touching that brake pedal. And so I believe in the way these tests are run, that leads to an advantage for the Tesla pulling in more of that energy, and it's probably something where real world the Taycan's going to be able to pull in some energy through regen and get a bit more efficiency there. But overall, the regen and motor efficiency advantage goes to the Model S, and that plays a healthy role in its 201-mile range advantage. Moving on to voluntary range reduction. So here's where the conspiracy theories go wild, but they don't need to. So for the Porsche Turbo, the Taycan Turbo, which has, when tested by the EPA, they found it had a range of 202 miles. Well, Porsche gave it a range of 201 miles. So they reduced it by 1 mile. And why would they do that? Well, basically it was a rounding difference. The EPA rounded up, Porsche decided to round down. Now on the Turbo S, the EPA got a rating of 200, whereas Porsche gave it a rating of 192. So why would they voluntarily take 8 miles off? Well, that's what Porsche got in their own testing. So they went with the number that they got in their testing rather than the number the EPA got. And honestly, I think it's probably more accurate of them to go with this strategy here, the 201, the 192, because the Turbo S versus the Turbo has more power, it has larger wheels, which we know make a significant difference on range, and it has wider tires. And so I would imagine that the actual difference in range between the two is probably larger than just 2 miles. So anyways, I think it makes sense the way they did it, and they didn't just say, hey, we're just going to choose these really conservative numbers. Those were the numbers Porsche got in their own testing, so that's what they went with. Now, surprise, surprise, Porsche is not the only one that's giving a voluntary reduction on their range. So Tesla actually does it with 3 of their models. The Model 3 Performance with 18-inch wheels has a rating from the EPA of 332. Voluntarily, Tesla took 10 miles off that range and gave it a rating of 322. Same story with the Model Y Long Range and the Model Y Performance, going from 320 down to 316 and from 316 down to 315 for those respective models. So Tesla also does this. There's some marketing aspects to it, some different reasons why you might want to provide a different rating than what you were given by the EPA. But regardless, both of these companies are doing it on certain models. Now, just to reiterate this 201-mile gap in range that the Tesla Model S has, the Porsche is only voluntarily taking away 1 of those 201 miles. So yes, part of it is explained by Porsche being conservative. 1 out of the 201 miles. Finally, we get to my favorite part, and that is road load. So this is extremely cool. basically, when a car is going down the road, there are forces resisting that motion. So there's, of course, aerodynamic drag, which increases with speed squared. We have rolling resistance from the tires on the ground. And there's, of course, internal friction going on, whether it's a transmission or bearings, things like that. You've got internal friction occurring within that vehicle that is preventing it from moving forward. And you, of course, use those electric motors to power through all of that. Now, companies have to provide an equation to the EPA that gives them what these resistive forces are. And the form of that equation is given as the force is equal to A, some constant, plus B, a constant multiplied by the vehicle's velocity, plus C, a constant multiplied by the vehicle's velocity squared. And so they have to provide this A, B, and C to the EPA so the EPA can draw out a plot of speed versus force. And so basically you can look at this equation and say, okay, if I'm traveling at 55 miles per hour, what force is resisting the car? And using the equations that the manufacturers provide to you, which if you cheat on, there's a big fine. It's not something you want to cheat on or lie about, and it does get checked. So ultimately, you have to provide that equation. Now you can look at these equations for the Porsche Turbo and the Tesla Model S Long Range Plus. And so for the Porsche, it's 49.9, that's our A, plus 0.43, that's our B, plus 0.0137, that's our C. And then for Tesla, those numbers are 30.6, 0.65, and 0.0094. You can see that last number significantly less here. So as velocity increases, that Tesla's advantage there is increasing. So for example, we can look at a plot of these side by side, and you can see that the Tesla Model S Long Range Plus has a significant advantage. At any given speed, the force acting on it is significantly lower. And so let's just look at a highway speed of, say, 75 miles per hour. For the Porsche, that results in a 159 pound force, and for the Tesla, that results in a 132 pound force. So as you can see, both cars are traveling at the same speed. The Porsche is going to require a lot more energy because it has a higher force resisting that motion. And so if we were to drive, for example, 200 miles, we can do the math and see how much energy, assuming we're just on this flat, straight path forever, we can see how much energy it would take based on this force here, and we'd get 63.3 kilowatt hours for the Porsche and 52.5 kilowatt hours for the Tesla. So as you can see, it takes significantly more energy for the Porsche to travel down that road. Another way of thinking about this, if you have the Porsche driving down the road at 75 miles per hour, the Tesla would have the same force resisting its motion when the Tesla is driving at 87 miles per hour. So 12 miles per hour faster without an energy penalty. Okay, so assuming our Porsche is perfectly efficient, we can travel 200 miles on 63.3 kilowatt hours. That's just overcoming those resistive forces. So our battery pack is larger than this. So our actual range using the Porsche's usable battery pack would be 265 miles. Now again, that's assuming perfect efficiency. It won't actually hit this, but it's an interesting number to compare with the Tesla, because the Tesla can travel 200 miles on 52.5 kilowatt hours. Let's say it's able to use 95% of a 100 kilowatt hour battery pack, then it can travel 362 miles with perfect efficiency. So what's interesting here is that this number is larger than the Porsche's range, and this number is smaller than the Tesla's range. So real world, the Porsche is probably going to do slightly better, or it has a massive efficiency disadvantage versus the Tesla here. But either way, even with perfect efficiency, this proves to you that the Tesla is not going to go 400 miles on the highway. And so that's kind of an interesting thing there of how we're presenting range when that range doesn't necessarily correlate with how far it will go on the highway. Now, if we look at a Model S performance versus the Taycan Turbo, not the Taycan Turbo S, their plots for resistive load as they're traveling down the road, this coast down test, actually line up near perfectly. So pretty interesting to see that the Model S performance and the Porsche Taycan Turbo actually have a very similar road load force, resistive forces acting on them as they travel down the road. I think the real important thing here is that we're given a range for a vehicle, and that range doesn't really correlate with how far it can travel on the highway. And so it would be beneficial to have hey, here's your highway range traveling at 75 miles per hour constant, and assuming, there's no wind, there's no rain, there's no strange conditions, but here's how far you can go at 75 miles per hour. And unfortunately, that test doesn't exist, and so we're left interpreting, the data that is out there, and it's difficult to know how far is an electric car actually going to go on the highway, which is what matters. No one cares. If you have 400 miles to drive around the city, that's going to take all day to use up. But on the highway, that's actually usable. And so for people who are buying EVs, they're concerned about what their highway range is. We don't really have a representative test to tell us what that is. That's the unfortunate thing. Car and Driver did an interesting comparison, traveling at 75 miles per hour constantly in both the Porsche Taycan Turbo S versus the Model S Performance with 21-inch wheels. One's rated at 192 miles, the Tesla's rated at 326 miles, and Car and Driver's results for the range for the vehicles 209 for the Taycan and 222 for the Model S. So very close in highway range, even though the Tesla is definitely more efficient and it has a higher range and it's probably going to do, further city miles. But as far as the highway range, it's very similar, and so that's wild to see because it has more battery pack and it has other advantages, and yet it's only beating this, by 13 miles. So overall, quick recap, what's playing the biggest impact on the Tesla having 201 additional miles over the Porsche Turbo? Well, the biggest three factors are battery capacity, regen and motor efficiency, and this road load. Now, the other two do play a role, EPA testing and voluntary reduction. These are the two that are going to be talked about the most, but they play a smaller impact versus the other ones. So fascinating stuff. Really excited about that Car and Driver article. You should definitely pick it up and give it a read. Thank you all so much for watching. If you have any questions or comments, of course, feel free to leave them below.